Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So we are given this problem, soup servings. You have two soups, two bowl of soups, you can say A and B, each starting with n milliliters. On every turn, one of the four serving operations is chosen at random, each with a probability of 0.25, independent of all the previous turns. Okay, what you can do is that you can pour 100 ml from type A and 0 ml from type B. Okay, so you are given two bowls A and B. Initially both have same, but you are given four operations in which one of the operation is that 100 ml you can pour from type A and 0 ml from type B, and similarly 75 ml from type A and 25 ml from type B, and so on. But you see in this, you can there is no operations where 0 ml from A is there and something from B is there. Okay, so you can see that no matter what operations you perform, the amount of soup which you pour from A, that is the content of A, will always decrease. It will always decrease, but the content of B will may or may not decrease. Okay, so there is no operation that pours 0 ml from A and 100 ml from B. The amounts from A and B are poured simultaneously during the turn, and you need to find some probability answer. Okay, so return the probability that A is used up before B plus half the probability that both are used at the same time. Okay, so initially you are given n ml, okay, n ml of A and n ml of B. Okay, when you are given some operations, operation 1, operation 2, operation 3, okay, these four operations you are given, and in on an average, you can say on an average, you are, okay, so on an average you are favoring the empty of B. Okay, you are favoring the empty of B, of A. Okay, because you see in all the operations, A is given more favor in being empty and B is given less favor, because there is only one operation where B is poured more. Okay, and each are equally likely, so each one of them is like 25% chance of happening. Okay, each one of them is 25%, so definitely only one operation is there where B is poured more. So A, I can tell that on an average A is more preferred. So if I tell that which will be empty first, you can say that that value will increase. So, okay, if I ask you a question, probability that which A will empty first. Okay, A will empty first. Okay, that increases, it increases this value. Let's say this probability is X. Okay, so this X increases as N increases. Okay, so you can see this actually also by taking a very small example. Let's say n equals to 50. Okay, so if you, for n equals to 50, it's already given in the question that if we perform either of the first two servings, soup A will become empty first. Okay, and if we perform the third operation, then I mean, if you perform the fourth operation, B will become empty first. But if you perform the third operations, A and B will simultaneously become empty first, and you be given like something like this. Okay, so since A is being more favored, okay, in a probability distribution. So I hope if you have a good idea of probability, you will understand that if in a distribution where A is the favoring, I mean the emptying of A is favored, then uh, the more the amount of pool is there, the more the amount of pool is there, the more operations you perform. Okay, so on an average, if you perform, let's say on an average you are performing an operation OP. Okay, OP of I may be 1 2 3 4. So this, you can say that this favors empty of A, favors empty A. Okay, this favors emptying of A, and definitely the probability that, therefore I can say that the probability that A will empty first, this value of X, increases as you perform more operations, as you do more operations. Okay, so if an operation on an average favors emptying A, the probability that A will empty first increases as you do more operations, right? And how can you do more operations? So if you are able to, do more operation, it means that, it simply means that n is more. N ml, the initial value which was given to you, is more. So you can say that if n is more, then this probability x increases. Okay, if it's increasing, definitely there will come a time when it becomes 1. Okay, so let's try to write a recursive solution to this first. Okay, what do I mean by recursive solution? Uh, let's say you want to find an answer, but what will be this answer? Initially you have a and b, both are nml, so you can empty like this, you can do something like this, then you can do something like this. I hope you understand what I mean. You are emptying a by 75 and b by 25 ml in this, and you can do also something 50-50. I hope you get things easily. You can do A25 and B75 also. So these are the four operations which you can do, and you need to calculate what will be the answers. Okay, so definitely you get an idea of recursion from here, because uh, we want to find AB, right? We want to find the states AB, recursion of AB, but these are dependent on what are all the operations that perform before this. Okay, so definitely we can try to write a recursive solution at first, and then gradually think how to optimize it and how to find this clipping value of x. Okay, initially we don't know anything, right? So you cannot say that what will be this clipping value, after which the probability will start giving 1. Okay, but let's approach and see how to get that value. So let's try to write the recursive function. As I told you, uh, you can just write a calc function, okay, which will take a and b, the contents of a and b. It will just return the contents of a and b, right? And if you already know recursion, so I hope you know it. Okay, so if you know recursion, I think you can easily know that there is a base case. Okay, so before writing the base case, let me do something like answer is 0. I need to return a double. Okay, answer is 0, and I will do something like this. I will do the first operation here, which will give me calc of this 100 comma b. Okay, and similarly all of these, I can just simply do all of this. Okay, and the states will definitely get changed. The states, okay, so by mistake it got submitted. The states will definitely get changed. A will reduce to 75 25. This will be 50 50, and you're just calculating things from the previous value of the state of recursion. Okay, so what you can do is that return answer here. I hope you get this thing easily. Now, what will be the base case of the recursion? Okay, the base cases will be something like, if both get emptied first, you want to return the half of the probability of that. Okay, half the probability that both are get emptied first. So if you do something like a less than equals to 0 and b less than equals to 0, if these happen simultaneously, you can definitely return zero point 0.5. And if A is emptying first, you are in the favor. The probability that A is used up before E. So you want to return that one. Okay. And if B is emptying first, you do not need to return in any occurrence, because you are not asked. Your question is that probability that A is used up before E plus half the probability that both soups are used at the same time. So the time when B is used before, you don't need to calculate that anyway. Okay, so you just return 0 in that case, and that's all. If you try to run this recursive function and try to see that in what value of n does this get you a wrong answer. Okay, so initially it should not actually be giving you a wrong answer. So let's try to see what was the error in our approach. What if I do a 1.0 here? I think that should not really matter. Uh, but yeah, let's try to check this out. Okay, so you are not calculating the probability, right? So probability will be 0.25 of this. I hope you understand. Each of the four occurrences is equally likely. So you need to multiply something like 1 by 4 with this every time. Okay, so I hope you get this thing easily. You need to multiply this 1.25 every time. Uh, if you try to run now and check, it should run just fine. You see it's running fine. So in order to calculate the limit, you try to check that what value it is giving you a TLE. Okay. So it's at n equals to 850, it gives you a TLE. If you try to optimize this, okay, so from recursion to memoization I'm doing. So recursion to recursive DP. So I hope you already know this if you are already following my DP playlist. So what we do to convert any recursive solution to recursive DP is that you make a DP table. Okay. So n cross 1 and vector of double uh, n plus 1, and you initialize all the values with -1, telling that you have not visited any states right now. And when you will visit those states, you just mark it. Okay. So you tell something like, if the states A and B are not visited, they are not -1, you just return the same states. Okay. No need to calculate. If it's already calculated, no need to calculate the recursive states again. Okay. So, and otherwise you just save your value dpav into your answer. So if you try to run this and check what is the case where it's failing, what is the value of n where it is failing. So you definitely need to write this vector double of this, and definitely pass it by reference, and you just try to submit it and check that uh, in what case it is failing. So you see now it's failing in a very large case. Okay. So but you also, by your observation, you also got to know that uh, this it will start giving one after some time. So you need to know when it will start giving one. You cannot say that. So just to have something like uh, I mean, just to have a good intuition, let's iterate through n and just try to get a rough value at first, and then will try to narrow down our search. So let's go from 1,000 to 10,000, and in the increments of 1,000. Okay. And just check that in which of the cases, let me just comment this out, and I will just check that in which of the cases my answer is close to 1. So I will just calculate answer using this calc function, which will give me this NNDP, and it will also see out an answer. Okay, and this will be definitely a double. This answer has to be a double. So I want to check that when is the time that I will just returning 0 here. When is the time that it starts to give me 1 always? Okay, so to find that, you can just run this and check that. You see 1e5, 1e minus 5, 10 to the power minus 5 of the actual answer will be accepted. So this is of the case 1,000, this is 2,000, this is 3,000, this is 4,000, and this is 5,000, and this is 6,000. So from 6,000 onwards, definitely it's 1. But you see, for 5,000 only, this is 10 to the power minus 1, this is 10 to the power minus 2, and so on. This is 10 to the power minus 5. So even if you approximate this whole thing to 1, it will not affect your answer, because answer is within 10 to the power minus 5 of the actual limit. So you can say that from 5,000 onwards only, you are getting something like 1. Okay. So all you need to do is that you just comment this out, and okay. So you see, if n exceeds something like 5,000, uh, return, what will you return? Return 1. Okay. So this give me a wrong answer. No, not a wrong answer. But I mean, if it still gives me a TLE, then I will uh, again narrow down my search to below 5,000. Okay. So let me try to submit this and check what does it give me accepted or what. So see, we do get an accepted answer for this, but the runtime complexity is not so cool. So another thing which you can observe here is that n is always a multiple of 25. So you can actually reduce your DP computations. Okay, you can always reduce your DP computations. So you see, uh, always our something like minus 25, minus 75, something like these are happening. So always in the multiples of 25, it is getting reduced. So I can say that I can divide the whole thing by 25, okay, and just say that when I was doing something like this, it would mean that a minus 4 and b, and a minus 3 and b minus 1. I hope you know that. I hope you know what I am trying to do. I am treating this 25 ml as 1 unit, okay, and trying to reduce my units so that my db table takes up much less values, okay. So trying to just improve the time complexity and nothing else. So a minus 2, b minus 2, and this will be a minus 1, b minus 3. I hope you understand this, what I did this. But let's say you need to take the seal value, okay. I hope you understand that, because n can be written as n plus by 25 plus n mod 25, right? This extra value, let's say you are having something like 102. So if you divide by 5, this will be 4 plus 2 ml will be extra left, right? 2 ml will be extra left, but you need to pour one more time. So this value will be 4 point something, 4 point something, and you need to take the seal of that. I hope you know what is the seal. 4 point something. If you take the seal value, we will get 5. 4.9, if you take the seal value, you will take 5. So that's how seal works actually. So you take the value which is just above you, but if you are just 4, if you take the seal of 4, you should get 4, because you are not in any point, you are not in any decimal number. So I hope you understand this. So what can I do is that I can just do that n is nothing but n by 25, seal of n by 25, okay. And what else can you do? You see, uh, you can reduce this, definitely. You should reduce this. This will be 3, this will be 1, this will be 2 and 2. So, and this will be, sorry, this will be 1 and 3. So I hope you understood what I just meant to say this. Let's try to submit it and check if our time complexity actually improved a little bit also. You see, we are getting a wrong answer actually. So you see, if you just are doing n by 25, so case where n equals to 1, you are just doing seal of 0, but definitely you need to do it something like 25. So the result gets double, and then you just calculate this seal of the double value. Okay, so that's what you should be doing. So let's try to submit now and check if it gives you a better runtime. You see, it gives you 100% bits as well as a very good memory runtime complexity. So yeah, I hope this problem was clear to you. This is a very unusual, not so good kind of problem, you can say, because this n equals to finding 5,000 is not something which will come to mind easily, or it also requires running running the code in order to find this value. Okay. Uh, I think this is not calculatable by hand, or is very difficult to calculate this 5,000 value. But I think this should click in your mind that probability will increase as the whole answer is favoring A. Okay, so yeah, that's all. I guess that's all for this problem. And I hope you have a very easy day ahead. Thank you so much.